In the next part of lesson 6, we're going to look at a little bit more of a complex model involving finance. And the formulas that we're going to use are more complex as well. What I did is I went ahead and formatted my spreadsheet to look like this table that's given in my open math. So you can see that I've copied the formatting here, right? The cell coloring, the coloring of the font to match this table in my open math. So pause this video and then copy the format from my open math into Excel. And when you're done, restart the video. Welcome back. You formatted your Excel spreadsheet. The company, Akron, is a large drug company. At the current time, beginning of the year 0, Akron is trying to decide whether one of its new drugs, Niagara, is worth pursuing. Niagara is in the final stages of development and will be ready to enter the market 1 year from now. The final cost of development to be incurred at the beginning of the year 1 is $16 million. Beginning of year 1 is times 0, right? Akron estimates that the demand for Niagara will gradually grow and then decline over its useful lifetime of 20 years. Specifically, the company expects its gross margin to be $1.6 million in year 1. Then to increase at an annual rate of 8.2% through year 8. And finally, to decrease at an annual rate of 4.6% through year 20. Now, your peak year might be different than mine. All the numbers in blue might be different than mine. Akron wants to develop a spreadsheet model of its 20-year cash flows, assuming its cash flows, other than the initial development cost, are incurred at the ends of the respective years. To simplify the modeling, taxes are ignored. Using an annual discount rate of 6.5% for the purposes of calculating net present value, the drug company wants to know if it should pursue the drug or abandon it now and not incur the $16 million development cost. So here are some solution hints. We're going to format cells A1 to E51, which I've already done, E51 down here to A1. In A6 to B6, we're going to name these blue cells these values. So the way we do that is we go to formulas, and it looks like we need to expand define names. You want to click create from selection, and then make sure the left column is check marked, not the top row, and then click OK. Now this cell is called peak year with an underscore. This is called rate of increase with underscores instead of spaces. That's the rate of decrease, and this right here is the discount rate. That's going to be really helpful in coding this. We want to copy the following formula cell B12, and we'll talk about this in a second. We're going to copy this to B12. We'll drop the discussion until we get to it. Then we want to double click the bottom right hand corner of cell B12 to copy the formula to cells B13 to B30. And we don't need it there. We just need it to B30. Development cost is $16 million. Notice that I have millions of dollars out here. Gross margin for year 1 is $1.61 million. The peak year is 8. It increases 8.2% through the peak year. Then it decreases at an annual rate of 4.6%. Now, this should be negative, but I can drop the negative sign if the modeling accounts for it later on. The discount rate is 6.5%. It's what you can do with your money instead of developing this drug. What could a company do with $16 million? Well, it could invest it in 20-year treasury. If that's the next best alternative, if that yield is 6.5%, then you can think of that as your discount rate. So let's go through and make sure we're entering the information incorrectly. That's 16. That is 1.61 in my model, $1 million. The peak year in my model is 8. The rate of increase is 8.2%. The rate of decrease is 4.6%. And the discount rate is 6.5%. Now I'm going to press enter to see if these answers are correct. If these three are marked incorrect, since there's no percent out here, no percent symbol out here, I'm suspecting that mathematics is going to mark them incorrect. So let's see if that is the case. It is. So we got to put a percent symbol in here on each one of these. Our gross margin year one is just 1.61. So here we're just going to type equal and then go up to 1.61. Now, when I press enter, it will replace all the zeros below it. We need 4 decimal places, so let's do that real quick. Okay, so what is going on here? Well, A12 is this number 2. This is end of year 2. So we're doing a Boolean. We're asking a question. Is 2 less than the peak year? The peak year is 8. So this is true. If this is true, which it is, 2 is less than 8, then we're going to take this B11, right? We're going to increase it. We're going to increase it by 8.2%. So all we're doing is we're taking the 1.61, multiplying by 1.082. We're increasing 1.61 by 8.2%. In year 3, we're doing the same thing. 3 is less than 8, less than or equal to 8. So we're taking the 1.7420, we're multiplying it by 1 plus the rate of increase, 8.2%. In year 4, the same thing. 4 is less than or equal to 8. So we're taking this 1.8849 and we're multiplying it by 1 plus the rate of increase. 5, the same thing. 6, the same thing. 7, the same thing. 8. This A18 is 8. 8 is less than or equal to the peak year. So again, we're doing what? We're multiplying the previous gross margin by this rate of increase. Now, what about year 9? In year 9, A19 is greater than 8. So this is no longer true. So we skip this. This comma says then. If this is true, then do this. Else, that comma there says else. So if this is not true, right, we're going to do this part here. And all we're doing is we're taking the B18, the previous year's gross margin, and we're multiplying it by 1 minus the rate of decrease. So 95.4% in my case, right? So what you'll see is when you go from year 8 to year 9, the gross margin falls. Since these years out here are all greater than the peak year 8, these values all decrease by that 4.6%. So we ignore that. Excel computes that all the way down. Cell's computing that. It's taking this times 1 minus the rate of decrease. This previous gross margin times 1 minus the rate of decrease, et cetera, until we get to year 20. Again, this is not true. So we're going to skip that. And we're going to do this. B29, that value, times 1 minus the rate of decrease. Now we need to calculate the net present value. In Excel, you can type NPV, parenthesis. Now you got to get the discount rate, 6.5%. And then you need the stream of payments, the stream of gross margins. We have 20 gross margins. And we get $23.43 million. This right here is the present value of gross margin. We want the net. N stands for net. This right here is, again, the present value of those payments. We got to subtract off the cost, right? The $16 million investment. So the present value was quite high. The net present value is a lot lower, $7.43 million. Now we need, again, 4 decimal places, right? I'm also going to get rid of the dollar sign because we have millions of dollars there. We don't need a dollar sign here. Having a dollar sign here would be redundant, right? So I'm going to pause the video, fill in these values, and then return. Welcome back. I got the gross margins here. I left this box empty, and I deleted the minus 16 million to show you that this is the present value of these gross margins. I'm going to copy this into here, and I should get it marked wrong because this is the present value of gross margins. See, I got that wrong. So what I have to do is I have to make it the net present value. And the net present value is subtracting off the development costs that we incur at the beginning of year 1. So let me copy this here and press enter again. There, we got it right. I also need to make this gray. Now we need to do what? We need to run a data table here. So what we're going to do here is we're going to type equal, and then we're going to go up to our net present value. Data tables are really kind of cool. They allow us to see how this object will change if we change the peak year. If we change the peak year. So right now the peak year is 8, right? How will this value change if the peak year was 4? How will it change if the peak year is 10? So let's go to data, what if analysis, and data table. These are in a column. So let's click on that. And then right here, peak year is 8. Okay. These numbers are all the same. If the peak year is 4, the net present value of the stream is very small. If somehow the peak year is 10, the net present value of the stream of payments is high, right? So we would desire the peak year to be 20 years, right? Or anything greater than 8. If we expect it to be 8, it'd be nice for it to be 9 or 10 or even 20, right? One way maybe to increase the peak year is to strengthen patent laws, make it more difficult for people to copy. Now we're going to do a two-way table where we're going to let the discount rate increase from 6% to 7% to 8% to 9%. And then we're going to do the same increase in the peak year. So to do a two-way table, this gray box, we want to, again, point to this net present value total, right? So this and that are pointing toward that. we're going to highlight this box all the way down to E51. So this is going to allow the discount rate to rise, and it's going to allow the peak year to rise. And again, we go to data, what if analysis, data table. Our column input cell is peak year, and our row input cell is the discount rate, 6.5%. And we click OK. What you can also do is you can go to Home, Conditional Formatting, highlight cells. You can do the top 10% green, and then you can do the bottom 10% red. Let's do this. We'll do the top five instead. And then we'll do the bottom 5. Instead. The bottom 5 will be in red. The top 5 are going to be in green. As the discount rate falls, and as the peak year increases, our profits tend to be high. So as we go down and to the left, as we go from here to here, our profit rise. So now we're going to plug in the information here. So this is that value and that value. I'm going to put you on pause while I fill out this table. All right, welcome back. I was able to put all the values from the Excel spreadsheet into the table in the math problem. And we got everything correct. Now, to really understand what the discount rate is doing, right? As the discount rate decreases, holding these constant, these net gross margins, the present value of net gross margins, they tend to increase, right? They increase. So we go from right to left, it's increasing. Why is that? Well, to understand that, let's go up here to this table. Now, what I did here is this decision is made at time 0. This is realized at the end of year 1. If this is realized, if this is paid at time 0, this is paid to you at time 1. This has to be discounted to time 0. And that's what we're doing here. We're discounting this 161. Actually, what I can do is I can just pull this down here. We're discounting this 161 here, 1.61. From the end of the year, this means end of the year. We want to discount it back to the beginning of the year, right? And the way we do that is we discount this 1 year. We discount this 1 year. How do we do that? We take the value, the 1.61, divide that by 1 plus the discount rate, 6.5%, and then raise it to the first power, right? Now I'm going to copy this down and see what happens. Now we're discounting this by the discount rate 2 years. So this is received at the end of year 2. We want to discount it to the beginning of year 1. This is received at the end of year 1. We want to discount it to the beginning of year 1. So we have to discount that value 1 period, 1 year, and we have to discount that 2 periods. Now we just do that for all of these values, all these 20 values here. We do that. Now, when we sum that, we're going to get what's called the present value of the gross margins. And these have all been discounted back to the beginning of year 1 times 0. And you can see that this is the same as that, right? Now, what did I do here? This right here is the Excel's way of calculating the present value of these gross margins. This is how you do it by hand. you sum these values that have been discounted by the number of years in the end of year column. Right. Now what we have to do is we have to subtract from both of these the cost of developing the product, the $16 million. And that's where this $7.4329 million comes from, right? Now, to understand the discount rate, if I change the discount rate to 0%, what happens? 1.61 discounted to the beginning of the year is 1.61. The 1.7420 discounted to the beginning of year one is 1.7420. The 1.5885 discounted by 20 years at a discount rate of 0% is 1.5885. So what does a 0% discount rate do? It weights the values near the end more than they would have otherwise been weighted. If the discount rate were, say, 100%, what would happen? All these future payments would have zero weight or near zero weight, wouldn't they? So as the discount rate goes to zero, we're more forward thinking. When I did my dissertation at Washington State University in 2004, I read a paper by, I think it was Christopher Swan, who was doing similar research in welfare reform. And I think he concluded that young males are more worried about today than young females. The female discount rate, I think, was about 20%, and the male discount rate was about 26%. So the lower the discount rate, the more people value the future than the present relative to those with a high discount rate. And that's how you can think of the discount rate. The people with 9% discount rates are more worried about the now. The people with 6% discount rates are more worried about the future. And so that's why if we hold the peak year constant, these net present values of this product rises.